Greetings and welcome to TAIL Module 2 Unit 4. This is related to the analysis phase of the ADDIE. And in the previous unit we understood the need to use an instructional system design model to reduce what do you call or to increase the quality of learning, and we said it is preferable to use an ISD model. And one of the model that we chose, is ADDIE model. ADDIE refers to analysis, design, development, implement and evaluate. And we also said this model is iterative and it is a systems type of model. That means you are going back and forth with a lot of feedbacks, that every element in that is going to influence every other element and so on. So it should be treated as we said, instructional system design model. And in this unit we will identify the sub process of analysis phase in the context of designing courses in engineering programs, and also understand the nature and role of sub processes of analysis phase, particularly course context and overview, concept map and course outcomes. So what needs to be understood is the ADDIE is such a generic model, it is applied to all types of things, any type of training program, any formal course, any short term course. It could be manual training program or any kind of on any subject, short term, long term, anything it can be applied. So what happens is the language or the elements of each phase or what we are calling as sub processes of each phase we have to identify. That is where you have the full choice. The sub process of each phase have to be identified in the context of designing courses in engineering programs. If it is non-engineering program, these sub processes may differ. So in the context of engineering programs we are trying to identify the sub processes, and even the sub processes that I am presenting are what a group of us felt are the appropriate ones, rather than they are not once again unique. You can also modify the sub processes and make the design of the course or the ADDIE version of your course your own. And in this particular unit we will be particularly looking at 3 of these sub processes, and the remaining ones we will look at in the following unit. The proposed activities of the analysis phase include writing the course context and overview, okay, and preparing the concept map of the course. Each one of them is a well defined activity. Writing course outcomes, creating sample assessment items for each one of the COs or the course outcomes, locating course outcomes in the taxonomy table, preparing the CO PSO matrix of the course, and elaborating each course outcome into several competencies. It could be total number of competencies could be 15 plus or minus 5. And having done all this, the output of the analysis phase is peer reviewed, and after the peer review you make the changes if they are needed. These are the activities of proposed analysis phase. And right now we will look at the first 3, namely writing the course context and overview, preparing the concept map of the course and writing course outcomes. Now first one is context of concern. As we all mentioned earlier, a course is an element of a program, and the program itself has to meet a certain number of outcomes, namely program outcomes and program specific outcomes. And further, a course may be a prerequisite to some other course, or a course expects certain prerequisites to be fulfilled by the students. So the course can never be seen in isolation. It is in a particular context. So now, and there is also context for the entire program. What kind of students come, what kind of curricular component does it belong to, and so on. Let us look at what is the context of concern for any course. First of all learners of a course belong to the same age group and have similar academic background. However, their cognitive abilities and motivations can considerably vary. That is one aspect. For example, in a context, especially in United States of America, the students who come to a course do not necessarily belong to the same age group. You have people who have worked for several years in the industry and are entering into an engineering program after considerable experience. Some of them are significant number of them could be graduates from the 12th standard. But you may have working mothers, single fathers, single mothers, you have all kinds of people like that. In such a case, organizing, designing and conducting the course will have to be somewhat different. So in Indian context, this is more or less, that is, all learners of a course belong to the same age group and they have similar academic background. That is one part. An engineering program has to attain POs identified by NBA and PSOs identified by department, and these have to be attained mainly or dominantly through core courses. That should be remembered. Electives do not come into picture of for NBA accreditation process. Not that the electives have nothing to do with POs and PSOs. Then all courses in engineering programs are elements of a pre-designed 4-year program. That means somebody has already designed the curriculum and there is a sequence of courses and it is a pre-designed, and a given course is an element of that. And every course belongs to a designated curricular component. All courses are of 1 semester duration and have to be conducted as per the predefined schedule, that is also constrained. All courses have similar assessment and evaluation mechanism, not identical but similar. In some programs, for example, especially related to management, not in as part of engineering program, outside, the course may not be of 1 semester duration. The course may happen only in 1 month in an intensive fashion. That will be quite different from normally in all engineering programs a course is spread over 1 semester. It has some characteristics which are desirable, but right now we will take it for granted. That is what do you call, this is what every course follows in engineering programs. Now based on this, course context and overview should be written, okay, and it should include 500 to 1500 words. In fact, it is good to write as much as you can. The elements of this course context and overview will include the following: category the course belongs to. For example, a course can come from humanities and social sciences, basic sciences, engineering sciences, professional core, professional elective, or an open elective. Okay, it can belong to any of these 7 categories. The semester it is offered, its prerequisites and the courses to which it is a prerequisite. For example, you can say a course A is offered in the 4th semester. and it has the following prerequisites. Unless the students take the prerequisite course, they cannot even understand this. Even if they are permitted to do that, they will not be able to do unless they have the prerequisite knowledge. And many times this course A is prerequisite to some other course B. Let us say a 4th semester course can be prerequisite to a 5th semester course or a 6th semester course. So one has to understand the sequence that should be written, like that point should need to be elaborated through a few sentences to explain the course context. Then one should write the broad aim of the course and its relevance to the program. One can write 2 or 3 sentences saying what is the broad aim of the course, why am I learning this, or what is it that I am learning. At the end, can I express the course in terms of 1 or 2 sentences, and then why should it be part of this program, why was it made as a part of this program. It may be a course in mechanical engineering, why am I learning a particular course in this branch. So somebody will have to explain. Generally the course, the curriculum designers will explain that, should explain that, or the instructor or the teacher who is designing the course can express his view of the relevance of the course to the program. And then broadly, if you consider, why am I learning this when I leave the program, when I get my degree? Okay, it is required for getting the degree, but is it really of any use to the profession I am going to likely to join? So the importance of the course to the profession, in the words of the teacher, should be explained preferably in a paragraph, where exactly this knowledge is likely to be used. The more the student is convinced of its importance to the profession, the more motivated he is likely to be. That is one of the ways of getting the explaining this will get the attention of the student in the course. Then the last one, what assumptions am I making in designing this course? Like what are the things that I consider important, or its applications, whatever assumptions that I am making I should explain in detail, and then the approach that as a teacher I am taking in the instruction and why am I taking that kind of approach thereof. So all these elements, these 5 elements should be elaborated into several paragraphs leading to 500 to 1500 words. If one spends a little time, it can be nice, the course context and overview can be nicely explained. You do not have to give the list of topics, and all that is not part of this. That will come at a different place. So course context and overview, when the student reads this, he internalizes why is doing this course and why is it important to his profession. Okay. That is what we call course context and overview. Now one of the things that we are going to do is to create what is called a course map, is concept map. Before that, we need to be clear that there are categories of knowledge that we have already identified in module 1. The general categories are factual, conceptual, procedural and metacognitive, and you have also Vincenti categories of engineering knowledge: fundamental design principles, criteria and specifications, practical constraints, design instrumentalities. Now one can look at a course from any of these knowledge categories. For example, I can look at it from factual perspective. What are the facts and facts I am going to learn? I organize my course in terms of the facts that I am going to pick up, but normally that is not done. So what we look at is, we generally consider a course can be organized as per conceptual knowledge or procedural knowledge or a combination of conceptual and procedural knowledge. In principle, it can be done by any of the three varieties. And here we are mainly looking at the concept map. This is a concept map is a graphical tool for organizing and representing conceptual knowledge. It is simple. That means we identify all the concepts that we consider are important in the course and organize them in some hierarchical fashion, linking one to the other. So, and present it graphically. And this tool has been developed more than 25 years ago at the University of Florida. There is a center called IHMC, and it has been developed there. One can go to that particular site and find out more about why this tool. It is still popular, it is still continuously getting evolved. There are lots of features, we will only look at some features relevant to us. So, concept map includes like this, it includes concepts and the relationship between concepts indicated by connecting line linking two concepts. You just connect by line, and then what happens? You write a linking phrase specifying the relationship between the two concepts. Only 3 elements in this. We will presently see the example. Now, how do we organize the concept map? They are represented in a hierarchical fashion with the most inclusive or most general concepts at the top of the map and more specific less general concepts arranged hierarchically below. So, a concept map can have several layers, but if you have too many layers it may look a bit intractable. We will find there are some simple artifacts that you can use to look it very elegant and useful to you. And also the hierarchical structure for a particular domain knowledge also depends on the context in which that knowledge is being applied or considered. So, there is nothing like universality about it. There is also in the context what is the most important concept and what is required to fully understand that concept, that depends on the context. And generally it is good to write one kind of a question for which we are seeking answer in a particular course. We will see from the example, if I am, let us say I am teaching a course on digital systems. So, what is the question I am trying to answer? I am trying to look for designing digital systems of certain kind. So, I am trying to design and I need to understand how to go about designing that. What kind of digital systems? I will clarify. Either you will say in that particular course I am trying to design both combinational and sequential circuits. Do I want to further qualify that sequential circuits? I can do so. So, by posing as a question or what we generally write as broad aim of the course, from there I can draw the concept map. Okay. These are the 3 principles. There is plenty of literature available on the internet. One can read that and understand the concept map. In my personal opinion, concept map is a great thing to create for a course. Now, the concept maps can be used to generate ideas like for brainstorming, to design complex structures, long tests, hypermedia, large websites, to communicate complex ideas, to aid learning by explicitly integrating new and old knowledge, and to assess understanding or diagnose misunderstanding. In fact, making students to draw a concept map, one can find out what are the misunderstandings of the individual. Okay. Concept map is one tool to organize the elements of a course, but there are other things, other types of maps. There is what is called mind map, there is what is called topic map, and so on. What happens here is the mind map is a very less structured than concept map. It has its own uses, so we are not straying into that. Concept map is a little more organized, structured. To that extent, it is also will have its own limitations, and topic maps are further more structured. So we will not worry about the topic maps and mind maps and mainly look at concept map here. And then what happens, we said each two concepts are connected by a link and with a proposition attached to that link statement. We will not read all this. These are some samples of propositions that we can use. For example, represent, show, consist of, include, varies. These are not really the action verbs that we talked about in the module 1 or in writing COs. These are just propositions that can link two concepts. Again, once again, by looking at the examples, we will be able to see. This may not be that very clear to see, but one can give this as a part of the notes, so you will have a chance to see it in detail. For example, this is a course on system software. See, we put a box there at the top and everything are box. Whatever that is written inside that box is a concept or a list of concepts. That is what you have to see. You cannot put a procedure inside the box. That is one mistake one is likely to make when first time you are working with concept maps. You should make sure whatever you put inside the box is actually a concept. So what is it that we have? We have here the highest concept is system software. System software, here we have a proposition is an. So when I read this and whatever that is written here, it should make sense. For example, system software is an interface between hardware and application software. That is what is written. And now once again when I go down, interface between hardware and application software consists of assemblers, loaders and linkers, macro processors, compilers, operating systems and text editor. So here what happened is I made a list of about 6 of them. So these 6 can be shown as 6 different boxes, but if I start expanding like 6 different boxes, the map becomes little more messy and complex. So I have listed all of them one by one here. That means when I list in a box, they are at the same level of hierarchy. If you look at this, there are 4 levels that we have, this and this and this, and there is one more here. So there are 4 levels and each level we are trying to set it up in line. In whatever way when you start writing the concept map, in the end you can clean it up to bring it into some kind of a structure like this. Okay. Now system software includes assemblers, and assemblers have machine dependent features and machine independent features, and assemblers can be single pass or multi pass assemblers. So single pass, multi pass, there are 2 different concepts, and machine dependent features is one concept and machine independent features is another concept. So that is how I am organizing, and what happens like this I handle all the things that I have here. For example, while I said operating systems is one of the elements of system software, but this course the way I am offering did not include that. because generally operating system is offered as an independent course, okay, or sometimes even compilers are offered as an independent course. So it all depends on what exactly you are trying to handle or what is the scope of their course, and all the related elements will have to be presented in this form. And now another feature of this concept map is when you are doing left to right, there is some inherent or implicit sequence is there. That means when I am offering, first I will try to present this part and then I come to assemblers. How many lectures do I take, that comes later, but that is a sequence in which I go. So left to right also represents not precisely but mostly the sequence in which we are going to deal with the topic. So you have second one, third one, fourth one and fifth one, okay. That is how you prepare the concept map. While creating the concept map it takes time, it takes a few hours or maybe a few days for 2 or 3 people to work together and create a satisfactory concept map. But one thing we can assure you, it is a very very interesting and satisfying exercise wherever we have done this kind of workshop of drawing the concept map. Now I will not go through the details of this. This is a map created by a professor who was teaching electromagnetic fields, and here this is beautiful way of looking at this particular subject. It is electric charges is the core, and electric charges can be static charges, moving charges or accelerating charges. That is how the entire course is structured and organized. So what happens is the student understands the relationship between all the topics that he is learning. For example, having done this, then we say, okay, we looked at the static charges and then I come to moving charges. So he can relate that how some properties of moving charges differ from static charges. A graphical representation is greatly helpful for the student to organize his knowledge internally. He will be able to relate one to the other very effectively. This is one example of another course. So a few aspects. CMap tool is very easy to use. The software is designed so beautifully, it takes only 5 minutes for you to start drawing the concept map. So you do not have to focus on the details of how to handle, what kind of program to write and so on. It is all graphic one. 5 minutes introduction is all that is required, and you can start you can focus on your subject rather than on the tool. And it has many editing features that enable you to create a good hierarchically organized CMap. You can put colors, you can organize them, you can put lots of things what you think will enhance the quality of the map. The CMap can be drawn based on the content given to you and or on your view of the subject. For example, the same content that is given to 2 teachers, they may create the 2 slightly different concept maps rather than the identical ones. So that represents your view of the subject. Faculty creating CMaps of their courses found it very enjoyable and enriching activity. If the concept map becomes unwieldy, there are too many elements, too many layers in that, then you can break it into multiple maps and still link one to the other. There are mechanisms in this. You can by linking one map to the one box, by double clicking that other map will open up in front. There are wonderful features in the tool, and incidentally this tool is free to download. It is an open source tool, and you can go to the same website or you just say CMap tool and you can get access to that and download and start working. Only thing, it is about 100 MB is the size of that. It takes some time for it to download. Now comes the course outcomes. Course outcomes present what the student should be able to do at the end of the course, and we have already seen in detail in the module 1 how to write course outcomes. So, we are not going to elaborate at this point of time how to write course outcomes. So, we will only summarize saying that course outcome statement should have the elements including action verb, categories of knowledge, conditions which are optional, and criteria which are also optional, and they are written in the framework of Anderson-Bloom-Vincenti taxonomy. And as per procedures we presented in detail in module 1 of same course. So, we expect whoever is going to the module 2, they have the knowledge of module 1, because we are not going to repeat all those elements or the taxonomy and how to write and all that at this point of time. Now, we also said the number of COs should be 6 plus or minus 2 for courses with 3:0:0, 3:1:0, and sometimes when the lab is integrated it will be 3:0:1. And if the number of credits are more or less, you can also adjust the number of outcomes that you want to write. And we also said course outcomes should be tagged with the POs and PSOs addressed are required to be addressed, and by the cognitive level. Generally the highest cognitive level you represent, you do not include the lower cognitive levels there. And also knowledge categories, because out of the 8 knowledge categories we are looking at, one may be addressing even up to 4 or 5 also. And the number of sessions that you have for number of class, laboratory, tutorial, field sessions, whatever you have. And this we have also stated. So, there are as many universities present their syllabus of a course as units. Some feel that the number of COs should be exactly equal to number of units. As we elaborated in module 1, there is no particular need for that. Unitization of syllabus was one of the administrative convenience and has no pedagogic bearing on writing outcomes. That means my outcome may go across the units, or one unit may have multiple outcomes and so on. So, you should not mix with units with outcomes. The number of COs should be decided by the nature and scope of the content, that is all. Now coming here, CMAPs and COs. Drawing CMAPs is not a prerequisite to writing COs. Let us make sure of that. It is not compulsory to write, but drawing CMAPs can greatly facilitate your understanding of the course and in writing good COs. That is what we can say. So, for writing COs it is not necessary, compulsory to write to prepare the CMAP. That should be remembered. And this is how the sample COs of electromagnetism course. This structure is also we have shown some other courses like this. So, you write the CO and then the POs and PSOs addressed, and then cognitive level, knowledge categories and class sessions and number of tutorial hours. That is how we present, and the rest of that. This is complete course on electromagnetism. Now at this point we would suggest that if you can please prepare a concept map of your course. As I said, it will be quite an enjoyable exercise and preferably in collaboration with a colleague, and write the COs of your course in the format given and with the tagging as per the procedure mentioned. This exercise we already asked in the module 1. If you have already done that, those things can be carried forward here, and the course outcome should be written in the kind of table that we have given you below, and we will be happy, we will thank you if you can share the results of your exercise with us. And in the next unit we will look at the remaining sub processes of analysis phase with respect to an engineering course. There are 4 other sub processes, or if you want you can say 5 sub processes. We will elaborate on that so that the analysis phase is completed in a systematic fashion. Thank you very much for your attention.